Let's look at the situation that leads to no solutions, or the situations that lead to no solutions. So one of these is three parallel planes. Three parallel planes never intersect, and therefore there's no point or set of points that are a solution. We could have one plane listed twice, which means, as with 2D, that it's like when we ended up with two lines that were actually the same line. We'd end up with two planes that are actually the same plane. But then we have a third parallel plane, and so there's, once again, no intersections. You could have two parallel planes and a third plane cutting across. You do get a line between two of the planes and a line between the other, but those lines are never going to intersect. You never get a single line of solutions. And you can have intersecting pairs of planes forming parallel lines. So we've got some lines here, lines down there. But once again, there's no single point where they come together, and we don't get a single line of solutions. We can recognize the first three cases shown above before we start trying to solve the system. And this is important. The first step in solving a system is look for these cases where you have parallel planes. This one we'll detect later on in the solution. The case on the right, which is often referred to as the Toblerone box, and you can see why, we formed a triangular box, can be identified once one variable has been eliminated. So let's suppose we get rid of z between our equations. You'll then see a situation where you can identify that case, the Toblerone box case. It goes something like this. You'll end up with something like 3x minus 2y equals 7 and 3x minus 2y equals 9. These are known as inconsistent equations because you've got the same left-hand side but a different right-hand side. And that's the classic case where you spot the Toblerone box.